Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular video is AQA New Practice Set 1, Higher Tier, Paper 1, Non-Calculator. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Okay, we have a nice gentle start to the paper here. We just need to compare the size of some decimal numbers. Now when comparing decimals, it'd be useful to have the same number of digits for both. So I'm going to add some extra digits to these numbers so they're easier to compare. So 2.31 is the same thing as 2.310. 2.3 with a dot on the top is the same thing as 2.333. Obviously there are going to be some more 3's in there as well. 2.33 is the same thing as 2.330, and then I've already got that one to 3 decimal places anyway. So now I've got the same number of decimal points in all of them. It's much easier to see that this one here is going to be the smallest. For part B, I now need to see which is the largest of our 4 numbers. I'm going to do the same thing. I'm going to add some extra decimal places to each of the numbers so they're easy to compare. So 7.1 is the same thing as 7.100. 7.1 with a dot on the top, reoccurring, is the same thing as 7.11. Well, there are more ones as well. And 7.11 is the same thing as 7.110, and I've already got that to 3 significant figures. So again, now I've got the same number of decimal places for all of them. It's very easy to see that that one is the largest. Okay, in question 2, we need to work out which of these expressions is the nth term of the sequence. Now to find the nth term of a sequence, you want to have a look at the gap between each of these numbers to start with. So you can see this sequence is going down in 5s. So that means that the nth term of this sequence is going to have something to do with minus 5n. Now normally we'd then have to go on and find out what this number is here, but actually that's all we need to do here because it's enough to rule out that one, and that one, because there's only the one expression in our choices that has minus 5n involved, so it has to be that one. Question 3 wants us to work out which of these is not a square number. Now if these numbers are all made up of 2 parts, so if they're square then each part of them needs to be a square. So you can see with this first one, 4 times 10 to the power 2, well that's 2 squared times 10 squared. So both parts of that number are squares, so the number itself is a square. You can do the same thing with 4 times 10 to the 6. That's 2 squared times 10 cubed squared. You can do the same thing with our last one as well. That's 3 squared times 10 squared all squared. But this number here, the first part is a square, that's 3 squared, but 10 cubed I can't express as a square, so this one has to be the not square number. Question 4 involves some decimal division, so to make life easier for myself, I'm going to first get rid of the decimal parts. So expressing this as a quotient, I can see that 64.32 divided by 0.12, and if I times top and bottom by 100, I'm going to make life a lot more easy for myself. That's 6,432 divided by 12, which is a bit more manageable. Now I can just do some short division to get the solution. So 12s into 6 don't go, 12s into 64 go 5 times, remainder 4. 12 into 43 goes 3 times, remainder 7, and 12 into 7 goes 6 times, remainder 0. So our solution is 536. Question 5 is about this scatter graph, which is showing the number of driving lessons that 10 candidates have against the number of tests they needed to pass. So you can see from here that as the number of driving lessons is increasing up the scale, so is the number of tests. So we clearly have strong positive correlation here. Now in the questions we're going to be going on to ask about that, so I can already say that correlation is strong positive. And then the next part of the question says, use a line of best fit to estimate the number of tests needed to pass by a person who has 50 lessons. So we're going to need to come back and put a line of best fit on this graph. So using your ruler, you want to place it in such a way as it passes through the points. You need to try and get the same sort of number on both sides of the line. Okay, looks about right to me. It's not a precise, exact science. You do get a bit of leeway either side. I think that looks about right. Okay, once I've got that on, I need to read up to the line of best fit from 50 and across. So again, putting the ruler on my graph at 50. So I'm going to need to read up to the graph at 50 and then along. Like so. And then this value here is my answer. So on this scale it's about 3.8 tests. So on average it takes about 3.8 tests for a person who has 50 lessons. Mira says, I can use the trend to predict the number of driving tests needed to pass for any number of driving lessons. And we need to comment on the accuracy of this statement. So if we come back and look at the graph, you can see that we've got data for students having between 30 and 65 tests, and within that range we clearly have strong positive correlation. What we don't have is any evidence or any data either side of that. So we've got no data for these low numbers here, and we've got no data for anything beyond 65 lessons. So whilst the data clearly shows strong positive correlation between 30 and 65, we've got no evidence that it does either side of that range. So I'm going to write here that estimates will only be accurate within the range of the data. Reliable, sorry. Between the range of the data, which we said was 30 to 65 lessons. In question 6 we're asked which fraction is closer to a half, 2/5 or 5/8. Now, whenever we're comparing fractions, the easiest thing to do is to make sure that all of we rewrite each fraction with a common denominator. So we're looking for a common denominator from 5, 8, and 2. So all three of those numbers go into 40. So I'm going to change them all into fractions over 40. So 2/5 is the same thing as, well, 5 goes into 40 8 times, so that's going to be 16/40. 5/8 is going to be the equivalent to 25/40, and we're comparing it to a half, which is 20/40. So the difference between 16/40 and 20/40 is 4, and the distance between 25/40 and 20/40 is 5. So I would say that 2/5 is the closest. Okay, on the diagram below, we're asked to shade an area that's represented by the expression AD plus CD. Now, some of the measurements are missing, but we can see because from here to here is A, then this is also going to be A here, and because from here to here is D, this is also going to be D here. So AD is going to be this central rectangle along here, so that's AD, and then CD can be either one of the smaller ones at the end. I'm going to pick that one there is CD, so between them that is the area AD plus CD. Well, the next diagram, we need to show the area represented by D times A plus 2C. Now, A plus 2C is, well, here's C, and here's C as well, and in between is A. So from here through to here is A plus 2C, and then we already know that that's D down there, so A plus 2C times D is all of this central part here. The final part of the question asks for an expression for the whole area of the shape. So this part here is A times B, this part here is CD, we've got another CD over here, in the center we had AD, and then we've got another AB down here. So altogether we've got 2 ABs, we've got 2 CDs, and we've got an AD. Question 8 wants us to circle the exact value of cos 30. Now, for your exam, you're going to need to know the exact values for the sine, cosine, and tangent for 0, 30, 45, 60, and 90. You've got two strategies really. You can either try and memorize the whole table, or you can learn how to derive them for yourself. I think the second method is better. I'm going to quickly show you how to derive cos 30 from an equilateral triangle. So the first thing we do is going to draw an equilateral triangle. This is an equilateral triangle of side 2. Now I'm going to divide this triangle into 2 equal right angle triangles. So these two are the same length, so the whole length is 2, so this part of it has to be 1. Now it's an equilateral triangle, so all the angles were 60. So because I cut this one in half up here, that one's going to have to be 30. And finally, I need to know the length of this side here. Using Pythagoras Theorem, I know that this side of a right angle triangle must be, I can use, well, it's the hypotenuse squared minus the shorter side squared, all square rooted. So that is equal to 2 squared, which is 4, take away 1 squared. So basically it's root 3. Okay. So using our knowledge of trigonometry, I want to know the cosine of this 30-degree angle here. Now, the cosine of an angle is equal to the adjacent over the hypotenuse. So from the 30-degree angle, this is the opposite, this is the adjacent, and this is the hypotenuse. So we need to know cos 30, which is the adjacent, which was our side here we worked out using Pythagoras Theorem, divided by the hypotenuse, which was 2. So the one we want is that one there. Question 9 concerns itself with this distance time graph. Now this is showing a race between 3 boys, Alan, Ben and Carl, over 1,000 meters. So we've got the time along the bottom and we've got the distance along the side. Okay, so normally who wins the race is the person who gets to the finish line first. So we should be looking at which of these 3 boys gets to the 1,000-meter mark before the others. So the 1,000-meter mark is here, this line. So I'll quickly draw that on. This is the finish line here. So you can see that Ben reaches it here, and then Alan and Carl reach it at the same time here. So the person who gets there first is Ben. He gets there at this point here at 4.5 minutes. So who won the race? Ben. So Ben won the race. Why? Because Ben finished after 4.5 minutes and Alan and Carl finished after 5 minutes. Okay, now the next part of the question asks us to describe the race, and it's worth 4 marks, so we need to come up with at least 4 statements about the graph. So we can read this graph from left to right, so you can see that as we start off that Alan starts off the fastest, so Alan is in the lead, then Ben is second and Carl is third for the first part of the race. At this point, at 2.5 minutes, Ben slows down. At 3 minutes, Alan stops for a while and then starts again soon after at a slower pace. At 3.5 minutes, Ben speeds up and then overtakes Alan. Carl speeds up at 4 minutes, but it's not enough to overtake anybody, but he does finish the race at the same time as Alan. So writing all that down in the question paper, at the start of the race Alan is fastest. After 2.5 minutes Ben slows down. After 3 minutes Alan stops. After 3.25 minutes Alan starts again but slower than before. After 3.5 minutes Ben speeds up. After 4 minutes Carl speeds up. After 4.25 minutes Ben overtakes Alan. After 4.5 minutes Ben finishes, and after 5 minutes Alan and Carl finish. So you can see I've written all those down just in chronological order, making a note of any changes along the way. Question 10 has a fairly straightforward pair of simultaneous linear equations. I'm going to be using the elimination method to solve this. Let's label that one equation 1 and equation 2. So to eliminate x, I'm going to take equation 1 and I'm going to subtract 2 lots of equation 2. So let's just write equation 1 out again. 2x plus 3y is equal to 15.5. And I'm going to write equation 2 underneath, but we're going to double everything up. So we're going to get 2x plus 2y equals 12. Okay, now we can simply subtract one equation from the other. 2x take away 2x there's nothing. That's what we've done. We've managed to eliminate x. 3y take away 2y leaves us y. And 15.5 take away 12 leaves us 3.5. Okay, so we found y. Now we need to find x. To do that, we just need to substitute that back into one of our original equations. So substitute y equals 3.5 into, which one looks easier? I think I'm going to substitute into equation 2. So x is what we want to find, plus y, which is 3.5, is equal to 6. So rearranging that, I'm going to get x equals 6 minus 3.5, which is going to give me 2.5, my answer for x. Okay, now I am done, but it's always a good idea to check. So checking both of our answers by substituting into the other equation that we didn't use to find x. Just quickly, so two lots of, so this is a check, isn't it? Check. 2 lots of x, 2 lots of 2.5 plus 3 lots of y, 3 lots of 3.5. Is that equal to 15.5? Okay, so 2 lots of 2.5 is 5, 3 lots of 3.5 is 10.5, and together, yes, they do make 15.5. So I'm quite happy that my answer is correct. Okay, so now I'm satisfied. I'm just going to write those two values in here. So x is 2.5 and y is 3.5. Okay, in this question, it's a bit of a puzzle. I've got 5 integers, and I know that the mode is 6, the median is 8, and the mean is 10. And I have to use these bits of information to work out what the greatest possible range might be for those 5 numbers. So let's go through one piece of information at a time and see if we can piece it all together. Now, the first piece of information is that there is a mode of 6, which means there needs to be at least 2 6s in my 5 values. Right, so I've got 5 spaces to fill. Okay, now I know that 2 of them must be 6s at least. There might be 3 or more, but we know that must be at least 2. Now, it's got a median of 8. Now, because there are 5 numbers, the middle one must be 8. Which means, because I have to have 2 6s, that these 2 here must be the 6s. So I've got rid of those. Okay, so I've got 6, 6, 8, and something and something. Okay, so I've dealt with my mode of 6 and my median of 8. Last piece of information has a mean of 10, which means if I add them all up and divide by 5, I should get 10. So 6 plus 8 plus something, that's going to be equal to 50 then, isn't it? Okay, which means that these two numbers together has got to be the difference between 50 and 6 plus 6 plus 8, which is 20. Now, clearly they need to be bigger than 8, otherwise I'm not going to have 8 as my median. The first number can't be 8 because then it would be bimodal, so the smallest value this one can be is a 9. So then the largest one that this one on the end can be is 21. Does that work? 6, 12, 20, 29, 30, 50. That's right, isn't it? So then the range of this is going to be 21 minus 6, which is 15. That's the largest it can be. So, what is the greatest possible range? The greatest possible range is 21 minus 6, which is 15. So we need to take this expression and rewrite it in the form a open brackets bx plus c. Okay, so we clearly need to multiply it all out, remove all the brackets, collect it all up, and then see if we can factorize something out of it. So let's start with the expression. 2 lots of 7x plus 4 minus 4 lots of x plus 6 plus 1. Let's remove the brackets. So 2 lots of 7x is 14x. 2 lots of 4 is 8. Minus 4 lots of x, which is minus 4x. Just take care with the minus signs here. I've got minus 4 lots of 6, so that's going to be minus 24 plus 1. So collecting up the like terms now, I've got 14x minus 4x, which is 10x, and I've got 8 subtract 24 plus 1, which gives me a negative 15. I'll subtract 15. Okay, so you can see here I've got 10 and 15. That has a common factor of 5, so we're going to take 5 out, and that leaves me 5 lots of 2x minus 3. Okay, so that is in the form a lots of bx plus c. A, b, and c are all integers, and a is greater than 1. So I'm happy with that. Let's write the answer in. 5 lots of 2x minus 3. Okay, in this question we need to use the scale drawing of France to work out the distance between Paris and Marseille. Now we've got the scale at the bottom, which says 1 centimetre represents 80 kilometres. Now take care, because often when schools reproduce these practice papers for their students, they don't quite reproduce them to the right specifications, and often when you're doing a practice paper, the paper you're working from is using a slightly different scale. Now according to the mark scheme, the distance from there to there should be 8.2 centimetres. Now if yours is a little bit bigger or a little bit smaller, it probably means that your reprographics department in your school has reproduced it at a slightly wrong scale. So don't panic about it. All you've got to do is take whatever measurement you find it is between these two distances here, and then use the scale appropriately. So the distance is going to be 8.2 centimetres. Now we need to convert that into kilometres. So if 1 centimetre represents 80 kilometres, then 8.2 centimetres is going to represent 8.2 lots of 80 kilometres. Okay, so we need to multiply these two things together. So 8.2 times 80, that is 656 kilometres. So we know that distance is 656 kilometres. We know that speed is equal to 100 kilometers per hour. We want to find time. Okay, so we know that average speed equals distance divided by time. So rearranging that for time, time is going to be equal to distance, 656 divided by average speed, which is 100. Okay, and then so that's going to give us 6.56 hours. So I'm going to round that off to 6.6 hours. Okay, so the final part of the question asks us to comment on how each assumption affects the accuracy of our estimate. So we've got two assumptions. We've got the assumption that the road is straight, and we've got the assumption that the average speed is 100 kilometers per hour. So let's take each one of those in turn. So let's assume, what's our assumption about the road being straight about? Well, clearly the road isn't going to be straight. It's going to have some turns in it. So road is not going to be entirely straight. So actually it's going to be longer than that distance. So if the distance is bigger, then our time would be longer, which means our estimate is low. So estimate is low. Now our second assumption is that we are traveling at 100 kilometers per hour. So if estimated speed is low, then estimated time would be what? So if I've underestimated the speed, then I'm dividing by a smaller number than I would otherwise do. So the real number would be higher than that, so the time would be lower. So that means the estimated time would be high. And vice versa. Okay. Okay, we've got a pilot of an aircraft and he wants to fly from A to D, but actually he's a little bit off course. So in fact he's flying from A to E instead. So the question is wanting to know how far off course he is. So we need to work out that distance DE. Now we can do that using similar triangles. We know that from here to here is 60 miles. So for every 60 miles, he's 1 mile off course. Okay, so by the time he's gone this distance, which is 60 plus 150, which is 210 miles, how far off course is he now? Okay, so we know in similar triangles that sides are always in the same ratio. So we know that the side DE divided by 210 is going to be the same as the side BC, which is 1 over AB, which is 60. In other words, DE is going to be 210 over 60, which is 21 over 6, or 3.5 miles. So 3.5 miles. So the next part of the question says, how should the aircraft have turned at C to fly directly towards D? So coming back to our diagram, basically the point C, it should have corrected its course and gone off in that direction there. So it needed to turn, it needed to turn this angle. Now that turn is clearly more than 1 degree, because that's 1 degree there, isn't it? So it's more than 1. It's just whether or not that this distance here is bigger than or smaller than 1. So we're saying that that's 1 degrees. This angle here is the same as that one. It's alternate to that one, if these two lines are parallel. Now, is this angle bigger or smaller than that one? Now I would say because this distance here is shorter than this distance here, then this angle here must be smaller than 1. So this angle here must be smaller than 1. So the angle of turn must be between 1 and 2 degrees. So I'm going to go for that one there. Okay, this shape is rotated 90 degrees clockwise about point A and then enlarged by a scale factor of -2 center B. I need to draw the final shape on the diagram. So taking our triangle and first rotating it 90 degrees clockwise about A. So this point here, if I go 90 degrees clockwise about A, is going to end up there. This point is 1, 2, 3 units to the left of A, so it's going to end up 3 units above. 1, 2, 3, it's going to end up there. And then finally this point down here is 1, 2, 3 units below and 3 units to the left of A. So rotating it 90 degrees, it's going to be 3 units to the left and 3 units up. It's going to be there. So our shape then, intermediate shape, is going to be here. Okay, then the next thing I need to do is enlarge it by a scale factor of -2 center B. Now a scale factor of -2 means each point is going to appear twice as far from the center of enlargement on the opposite side. So taking this point here first off, it's 1 unit away from the center of enlargement, so its image is going to be 2 units on the opposite side. It's going to be there. The second point is 3 units away to start off with from the center of enlargement, so its image is going to be 3 times 2, which is 6 units above, so 1, 2, 3, 4, 5, 6 is going to be there. Finally, this last point is kind of 1 unit below and 3 along from the center, so multiplying that by a factor of 2 and it appearing on the opposite side, it's going to be 2 above and 6 along. It's going to be there. So then again, joining my shape together, my final shape is here. Okay, so in this question we need to rearrange this equation to make x a subject. Now note that x is appearing in 2 separate places here. So somehow we're going to have to get these 2 things to join up again in order to make x a subject. Okay, so let's start with what we've got. Y equals 4 minus 3x over x minus 5. First thing I can do is cross multiply this x minus 5 to the other side of the equation, giving me y lots of x minus 5 is equal to 4 minus 3x. Okay, removing the brackets, I get xy minus 5y equals 4 minus 3x. Collecting all the terms to do with x on the left and everything else on the right, I'm going to get xy plus 3x equals 4 plus 5y. Okay. Then I can factorize x out of my 2 terms. So x, open brackets, y plus 3 equals 4 plus 5y. And then finally cross multiplying the y plus 3 is going to give me x equals 4 plus 5y all over y plus 3, which is the answer I'm going to write in the box. Okay, so the diagram shows a rectangle inside a semicircle. The rectangle is dimension 16 centimeters by 6 centimeters, and we need to work out the shaded area. So you can see this shaded area then is half a circle, a semicircle, with that rectangle taken out of it. So finding the area of the rectangle is pretty straightforward. What we need in order to work out the area of the circle is going to be the radius. That's going to be the tricky bit. Okay, So we know the dimensions of the rectangle. It's 6, and from here to here is going to be 16. Now the center of the circle, of which the semicircle is half, is going to be here, isn't it? So that is going to be halfway between there and there. In other words, this half is going to be 8. Okay, now if I draw a radius from here to here, then I can use Pythagoras Theorem to then work out what the radius of this circle is. I've got 8 and 6 here, so well, you should recognize that really. This is a Pythagorean triple. So we've got our classic 3, 4, 5 Pythagorean triple. Now this one is double that, it's 6, 8, so it's going to be 10. So the radius of this circle is going to be 10 centimeters. Okay, so now we know the radius of the circle. It's fairly straightforward to work out the rest. So, okay, so our shaded area is going to be the area of the semicircle subtract the area of the rectangle. Now, a semicircle is going to have an area of half pi r squared, and the rectangle has area length times width. So subbing in what we know, that's half pi. We worked out that the radius was 10, and the length and width of the rectangle is 16 times 6. So 10 squared is 100, divided by 2 is 50 pi, minus 16 sixes. What's that then? 10 sixes is 60, and 6 sixes are 36, so that's 96. So 50 pi minus 96. Okay, so in this equation, in this problem, we need to work out what the coordinates of t are. Now t is this one up here. Now we're told that B is the midpoint of AC. So here's A, here's C, and here's the midpoint B. So we're going to use these two coordinates to find the coordinates of B. Once we've done that, then we can use this ratio TB to BS to work up from S, the distance from S to B, and then we can scale it up to work out the distance from B to T, and therefore work out the coordinates. Okay, so that's our kind of overall strategy and plan. Let's see if we can put that into action then. Let's start by working out the coordinates of B. So, midpoint. So I'll just get rid of that. So B is the midpoint of AC, so it has coordinates. So let's average out the x and the y coordinates. So the x coordinates of A and C are 15 and 23, so we need to average those. And we need to average the y coordinates as well, which is 6 and 12, so averaging those out. That tells me that B has coordinates 15 plus 23 is 38, divided by 2 is 19. And the y coordinate 6 plus 2, 18 divided by 2 is 9. So B has coordinates 19, 9. Add that to the diagram, 19, 9. Right, what now? So now we want to work out what T is. So we know the ratio of this part to this part is in the ratio of, what was it? 2 to 3. So this is 3 parts for every 2 parts that are here. So if we take the distance from B to S, we divide it by 3 and then multiply it up by 2, we should then be able to work out the distance from B to T. That's the plan. So 31 take away 19 divided by 3 and then times by 2 is going to give me 12 divided by 3 is 4 times 2 is 8. And with the y coordinates, doing the same thing. So 9 take away 3 divided by 3 and times by 2. 9 take away 3 is 6, divided by 3 is 2 times 2 is 4. So that is the distance to the left and up from B to get to T. So if I go 8 units to the left of B, I'm going to be at 11. 19 take away 8 is 11. And if I go 4 units up from B, 9 plus 4 is 13. So I'm going to get the coordinates of T of 11, 13. Okay, I've got a cuboid here, and it's got dimensions x, x, and y, which means it's kind of got a square end here. And x is going to be increased by 10%, and y is going to be decreased by 20%, and we want to work out what that means in terms of the overall percentage change of the volume. Now, if I'm going to increase these two by a factor of 10%, I'm going to then make them 110% of what they were before, which is a scale factor of 100. Well, so that's going to be 110%, which is a scale factor of 1.1. A decrease of 20%, 100% take away 20% is 80%, which is a scale factor of 0.8. So I'm going to be multiplying this one by a scale factor of 1.1. I'm going to be multiplying this one by a scale factor of 1.1. I'm going to be multiplying this one by a scale factor of 0.8. So the overall change in the volume of the cuboid is what I'm going to get. So percentage change, well, the change is (1.1) times 1.1 times 0.8. So 1.1 times 1.1 I know is 1.21 because I know my squares. And I need to times that by 0.8. So 1.21 times 0.8. So 8, 16, and 1. So what's that? 1, 2, 3 after the decimal point, so it's there. It's 0.968. So that's equal to 0.968, which as a percentage is 96.8%, and therefore the percentage change is the difference between that and 100%. So actually this isn't the percentage change, is it? So the percentage change is going to be 100%. The difference between 100% and 96.8%, which is a 3.2% decrease. In this question, we need to circle the value equivalent to 9 to the power of minus 1/2. Now, with these compound indices, you can actually treat them as two separate processes. I've got a negative index and I've got a power half, and I can treat those as two separate steps. So if I take 9 and I want to raise it to the power of negative 1/2, let's deal with the negative sign first. So a negative index means 1 over the positive version of that index. So I've dealt with that bit first. Now let's deal with the power half. Power half means the square root of. So that is equivalent to 1 over the square root of 9, and the square root of 9 is 1/3. So the solution we're looking for is that one. Okay, a bit more algebra now. I need to expand and simplify these three brackets. I need to basically multiply it out using double brackets and then another bracket. So it's a little bit easier than it first looks, because actually this part is what we call a difference of two squares, so the middle part is going to disappear, isn't it? So 2x times 2x is 4x squared, and then the two middle terms are going to disappear because I'm going to get a plus 10x and a minus 10x, and it's just going to leave me with the minus 25 part. So knowing your difference of two squares, a plus b, a minus b equals a squared minus b squared identity, makes these sorts of multiplications a little bit easier to do. So I've got 4x squared minus 25 equals 3x plus 7. So then using FOIL to multiply these out, or whichever method you usually use, I'm going to have 4x squared times 3x, which is going to give me 12x cubed. Then I've got 4x squared times 7, which is 4 7s are 28, 28x squared. Next up, I've got minus 25 times 3x, which is minus 75x. And finally, minus 25 times positive 7, which is 100 minus 175. Okay, I've got no like terms there. I've got a cube, a square, an x term, and a number. So I can't really simplify it any more than that. It's all done. Okay, time for a little bit of fun with surds. I've got quite a horrendous looking sum here. 26 over root 2 minus 12 over root 18 plus 2 root 50. And I need to somehow rearrange this so it's in the form of a root 2, where a is an integer. Okay, so how are we going to proceed? Well, I've kind of spotted that 2 times 18 is 36, which is a square number. So by putting those first two fractions, making them I'll put them over one denominator, they should simplify. So let's try that. So I've got root 2 on the bottom of that one and root 18. So I'm going to put my common denominator as root 2 root 18. So you can see that this root 2 goes into root 2 root 18 times. So if I multiply 26 by root 18, that kind of works. I've got a minus sign there. And the same, I've got 12 over root 18. So root 18 goes into root 2 root 18 root 2 times. So that's going to be 12 root 2 on the top. I've still got that 2 root 50 I haven't done anything with yet. So I'm just going to leave it there. Okay, we spotted earlier that 2 times 18 was 36. So the idea was to make that root 36 on the bottom. Now, root 18, now 18 is 9 times 2. So I'm going to rewrite that as 26 root 9 times 2. Just going to leave the 12 root 2 for now. And I've still got this 2 root 50 on the end that I haven't done anything with yet. What can I do with that? Well, 50 is 25 times 2. So let's change that to 25 times 2. Okay, now what can we do? Well, our denominator, root 36, is going to simplify down to 6 because the square root of 36 is 6. Now, breaking up this root 9 times 2, the square root of 9 is 3. And the square root of 2 is just the square root of 2, but I can bring the 9 out then, can't I? So that's going to give me 3 lots of 26. 3 lots of 26 is 26, 52, 72, 78. So 78 root 2 minus 12 root 2 plus, we can do something similar with this 25. I can break root of 25 times 2 into the root of 25 times the root of 2. The root of 25 is 5, so 2 times 5 is 10, so that becomes 10 root 2 there. Okay, now this is working out nicely. So 78 root 2 minus 12 root 2. Well, if you've got 78 of something, you take away 12 of that something, that same something, it's going to leave you with 78 take away 12, which is 66. So I'm going to get 66 root 2 over 6 plus 10 root 2. So then I can divide my 6 into my 66, leaving 11. So that's going to give me 11 root 2 plus 10 root 2, which altogether is 21 root 2. Okay, so it's in the form a root 2 where a is an integer, so our integer is 21. So 21 root 2 is the solution. Okay, so we've been given the curve of y equals sine x, and we've been asked to sketch on the graph the equation y equals sine x minus 1, which is just a transformation of our original graph. So basically, if you take a graph y is equal to f of x, and you translate that into a graph y equals f of x minus 1, then basically what you're doing is you are doing a translation of 1 unit, well, negative 1 unit in the direction of y. So that would be minus 1 unit. So we're going to go 1 unit down basically. So every point on this curve is going to be 1 unit lower on the graph y equals sine x minus 1. So let's take all the points on our curve that we can easily find the coordinates for. So we've got a coordinate at 0, 0. That's going to move 1 point down, so it's going to be there. I've got a coordinate at 91, so that one is going to be 1 lower. It's there. I've got a point at 180, 0. That's going to be 1 lower. It's going to be there. And then I've got a coordinate at 270 minus 1. So that's going to end up at 270 minus 2. And then finally, I've got a coordinate at 360, 0. It's going to be 1 lower at 360 minus 1. So once I've got all my points, I can just join them up with a curve. Like that. Bit wobbly at the end, but let's see if I can draw that bit again. Okay, that's better. So that's my transformed curve. Right, what's the next one about? Okay, now this time I need to sketch the graph of y equals minus sine x. So if I've got a graph y, y equals f of x, and then it goes to y equals minus f of x, then this is a reflection in the x-axis. Okay, so that means every point on my reference graph y equals sine x is going to be reflected in the x-axis. So again, we're going to go through point at a time, and work out where all the image points are going to be. So 0, 0, it's on the mirror line, so that's going to end up in the same place. This point at 91, if I reflect it in the mirror line, which is the x-axis, it's going to end up down there. 180, 0 again is on the mirror line, so it stays where it is. 270 minus 1 is going to be reflected to the opposite side, up there, and then again this one is going to be untouched because it's on the mirror line. So I've got all my reference points again now, so I can then join them up. Again, a bit wobbly at the end there. Let's just do that bit again. Okay, happy with that? Looks okay. It's again a bit wobbly, but hey. Right, finally, on this graph, sketch the graph of y equals tan x. So basically we just need to remember what the tan curve looks like. So if you remember, the tan graph has a period of 180 degrees, and it has asymptotes at 90, and then also at every 180 degrees after that, so it's going to have another asymptote there at 270. Okay, it's going to go through 0, 0, and it's going to pass through 180, and it's going to pass through 360. So the curve basically goes up and approaches the asymptote there, kind of zooms around the universe and reappears down there, passing through 180, 0. Again, approaching that asymptote, around the universe and back again, reappearing down here, and then going back through. Okay, so our bag contains n beads. One bead is black and the rest are white, which means that the number of white beads is n minus 1. So 2 beads are taken from the bag at random. So let's just do a quick tree diagram of that so I can be clear in my head what's going on. So at the first selection, the probability then that it's, well, it's either going to be white or it's not white. So the probability it's going to be white is n minus 1 white beads over n beads. And then obviously it's going to be 1 over n chance it's not white. And then a second selection, it's going to be 1 less bead in the bag at this point, so the denominator is going to be n minus 1. And if I picked white last time, I've now got 1 less white bead as well, so that's going to be n minus 2 there. And then I've still got, if I pick white first time, I've still got 1 not white bead there, so that's going to be 1 over n minus 1. If I pick the black bead last time, well, there isn't a choice, is there, because there's only white ones left, so actually that ends down there. So okay, so that's it then, isn't it? So what's the probability then that both beads are white? It's going to be this value here times this one here. So probability of white equals n minus 1 over n times n minus 2 over n minus 1. Oh, look at that. These two things cancel each other out, and it just leaves you with n minus 2 over n. Huzzah, we got there. Okay. Next part of the question. The probability that both beads are white is greater than 0.9. Work out the least possible value of n. So we just worked out that the probability of white was n minus 2 over n, and we're now told that that is greater than 0.9. So what we want to do then is basically we want to rearrange this and make n the subject. So cross multiplying my n, I'm going to have n minus 2 is greater than 0.9 n. Then so n take away 0.9 n is greater than 2. So n take away 0.9 n is going to be 0.1 n. 0.1 n is greater than 2, so multiplying through by 10, I'm going to get n is greater than 20. Now we need to make sure that we answer the question that we've been given. Now we've been told to work out the least possible value of n. Now I've worked out that n must be greater than 21, so the least possible value that n can take is 21. So on to vectors. ABCD is a parallelogram. We know that ABE is a straight line and AB to BE is in the ratio of 3 to 2. So AB to BE is in the ratio of 3 to 2. So B to E is going to have to be a fraction of A to B then, isn't it? So if I take A and I divide it by 3 and I times it by 2, then it means that B to E is going to be 2/3 of A. It also says that BC and ED intersect at F. I'm sure we're going to have to use something to do with that a bit later on. But first off, we just need to show that, or to work out the vector E to D. So here's E down here, and here's D up here. So with vectors, we need to go along routes that we know about. So from getting from E to D, I'm going to have to go this way along here and up there. Okay, that's the route I need to go. So let's work that out then. E to D is going to be E to A plus A to D, and we know that E to A is going to be minus 2/3 of A minus another A plus B. So how many A's is that then? I've got minus 2/3 and another minus 1, so that makes minus 5/3 altogether. So it's going to be B minus 5/3 of A. Okay, let's go on to the next part then. Deduce that E to F, so deduce E to F in terms of A and B. So where's E to F? Okay, now looking at this triangle here, we can see it is similar to this large triangle. So the ratio of the bigger triangle is 5 to 2, because this was 2/3, look, and then from here all the way along to here was 5/3. So the small triangle is in a ratio, or the small triangle to the big triangle is in a ratio of 2 to 5, which means that this side here is going to be 2/5 of B. So from B to F, that's going to be 2B over 5. So then E to F is going to be minus 2/3 of A plus 2B over 5. So E to F is going to be, we say what, 2B over 5 minus, what was it? 2/3 of A. Well, that's the end of the paper. Not too bad, I hope. Let me know how you did in the comments, and if you have any unanswered questions, why not ask them below. If you didn't do so well, time to hit the books a bit more and then come back and try another past paper in a few days. I'll be here to help you through that one too. And if you haven't already done so, why not subscribe so you can find me again for the next practice paper. Work hard, keep trying your best, and you will make progress. See you again next time.